Now we take an example to understand the application of the Neyman-Pearson's lemma. The statement of the example is that a random sample of size n from a normal distribution with sigma square is equal to 1 is to be used to test the hypothesis that mu is equal to mu naught against the alternative that mu is equal to mu 1, where mu 1 could be greater than mu naught. We actually consider only the one side of this test because h naught that is equal to mu 1, it means that either mu is greater than mu 1 or it could be mu is less than mu 1. दोनों possibilities इसमें हो सकती हैं. For in this example we just consider only the one possibility. उसके बिल्कुल parallel alternative possibility को भी हम discuss कर सकते हैं. So we here in this example we just consider only mu 1 is greater than mu naught. So use Neyman-Pearson's lemma to find the most powerful critical region of size alpha. So how we proceed for this one? So first we have to write down the likelihood functions of the two under null and alternative hypothesis. So the likelihood function under the null hypothesis I just representing L naught, that is equal to, for the normal distribution with sigma square is 1, so that is 1 over 2 pi, that is n over 2 into e raised to power minus 1 by 2 sum x minus mu naught square. And similarly the likelihood function on the basis of alternative hypothesis I just represented L1, that is 1 over 2 pi raised to power n over 2 into e raised to power minus 1 by 2 sum x minus mu 1 whole square. Then we need the ratio of these two, that is L naught over L1, and when we are going to take the ratio of these two, these constants are going to cancel out and the rest of things are this one, that is e raised to power minus 1 by 2 sum x minus mu naught square, और ये जब ऊपर जाएगा तो ये पॉजिटिव हो जाएगा. So that is 1 plus 1 over 2 sum x minus mu 1 square. So by using इसको थोड़ा सा अगर हम सिंप्लीफाई करके लिख लें तो आई थिंक इट विल बी मोर कन्वीनियंट फॉर अस जस्ट ओपनिंग द स्क्वायर्स, और इसको जब हम सिंप्लीफाई करेंगे तो ये हमारे पास जो रिजल्ट आएगा दैट विल बी e raised to power 1 by 2 n into mu 1 square minus mu naught square plus sum x into mu naught minus mu 1. स्केयर्स को ओपन किया है और इसको सिंप्लीफाई किया है तो वी विल फाइंड दिस रिजल्ट. नो बाय यूजिंग द न्यूमैन-पियर्सन क्राइटेरिया, बाय द नेमैन lemma, the test is rejected h naught when, that is L naught over L1, that is greater than or equal to k, the first criteria which we studied in the Neyman-Pearson's lemma. So after simplifying, putting this value of ratio, that is e raised to power 1 by 2 n into mu 1 square minus mu naught square plus sum x into mu naught minus mu 1 greater than or equal to k. So taking log on both sides, we get n over 2 mu 1 square minus mu naught square plus, this is constant, so we can write it as mu naught minus mu 1 into some x is greater than or equal to log of k. So further simplifying the terms, this is the constant, so we can take it in the other side, so that is basically, and this is also the constant, we can also take it to the other side. So actually we have, that is some x, and we just divide it by n and also divide by the other side, so that is basically greater than or equal to log k minus n by 2 mu 1 square minus mu naught square divide by, that is n, जो हमने इधर भी divide किया इधर भी किया, that is n, and that is mu naught minus mu 1. So let we assume that whole factor, बजाय ये सारा factor लिखने के, we assume that is equal to c. So actually x bar is greater than or equal to c, and we know that the distribution of x bar, that is actually normal with mean mu and variance 1 over n. Thus when we consider alpha, which is actually the probability of rejecting H naught, that is alpha is equal to probability under the null hypothesis, that is x bar greater than or equal to c. Then as we know that x bar follow the normal distribution and under the null hypothesis, so mu will be mu naught and variance is 1 over n when H naught is true. Now we find this probability, that is probability under the null hypothesis, that is x bar greater than or equal to c is equal to alpha, and that is actually the probability of x bar, basically that is under root n into x bar minus mu naught must be greater than or equal to c, basically that is under root n, and for the c value which we just assume that is equal to c minus mu naught, where z basically the standard normal distribution with mean 0 and variance 1, and the under root n c minus mu naught is actually the z alpha. So the test is, so the test is reject H naught if z is, keeping in view this criteria, z is greater than or equal to z alpha, and this is the most powerful test of size alpha. Now we use this for the practical situation. Suppose we assume some values mu naught, let's say that is equal to 0, mu 1 that is equal to, let's say 1, let's say n is 25, x bar is assumed to be, let's say that is 0.2, and alpha is 0.05. Now we calculate reject h naught if z is greater than z alpha. So z basically that is equal to 5 into 0.2 minus 0 under root n, that is 5. So that is actually equal to 1, and z that is on alpha, which is 0.5, and we know that its value is 1.645. so we can not reject h naught, because it should be, the value of z should be greater than 1.645, then we will reject. So in this case the value of z is less than 1.645, so we cannot reject h naught. But if the level of significance is changed, we may accept h naught. So also you can test the other way of this test. Initially we assume that the alternative actually that is mu 1 is greater than mu naught. You can also test alternative that is mu 1 is less than mu naught on the same lines by doing the same procedure. So in this case just only one thing must keep in mind: the rejection region is now going to change. The rejection region will be, in this case, that is x bar less than c. So in this case the probability that x bar under the null hypothesis less than c is equal to alpha, we have to evaluate this one. So you just only use z alpha instead of minus z alpha, and then you perform the same procedure as we did for the mu 1 is greater than mu naught, and you can define the best critical region on the same way.